Good morning. This is a video exploring the conveyor belt macros that are in ZebraCut, and specifically the modern belt generator. So I have here a Rhino 8 and ZebraCut 5, and we have installed the belt macro plugin. If we go to the Generate tab, you see we can generate all sorts of geometry from cardboard boxes, gaskets, but today we're going to be talking about the belt macros. If you don't see these options, you don't have the plugin installed, and you need to install the belt generator plugin. We're going to be focusing on the modern belt generators. You can see other videos for the legacy straight and circular ones. We're going to focus on modern. Once you've selected a generator, you can go ahead and select a configuration. There are some examples here in white, and any custom configurations you've saved will be in orange. To generate a given configuration, we're just going to select it, in this case an example straight belt, and we press generate. Your belt will then be generated, and you'll see we have the geometry here. We have several layers here. I'm just going to click on different ones so I can turn it on and off. So green is our cut layer, where we're going to cut out sides. Fittings are in yellow. You can change these colours in the settings if you'd like. And then if we have any additional fabrication, that will be in pink. So that's essentially how we create the belts. You can choose all sorts of different configurations. So here's an angled one, for example. So now we have an angled join. And we can see, of course, I've got fittings here, fabrication marks here on this example. And we can also do a circular belt. And the advantage of the modern belt generator is that it can produce all three types of belt with no problems at all. So lots of options in the modern system, and it can generate all different types of forms of belt, straight, angled, and circular. Okay, if you want to create your own configuration, what you need to do, well, is to click on the plus button. You save this as a new file, or you can overwrite an existing file. This will then bring up the options here, and there's a lot of different options, but the most important one is under here, and this is the name of it. So this is going to be our video belt macro, and that's the name that will appear in the list of drop downs here. So there's our video belt macro. Once we've saved it, we can validate the data, make sure that it's all valid. Very important that you do that. And you can save, and then you can go ahead and generate it. So that's just going to generate a very simple belt macro. If at any point you want to edit your configurations, you can just click on the double gears. So select it and go on the double gears. A good starting point is the examples. If you wanted to start making a circular belt, I would select that and then go to the gears, and you can start changing that. But we're going to work off of our video belt macro here. We'll have a look at some of the options that appear. So let's start with a straightforward option. Let's look at the inner teeth. We've got three options in here. If you click on any option, you can get more information about it in this little bar at the bottom. Inner teeth, we can choose the form. So for example, I'm going to say no teeth, and we just get a rectangle. Not very interesting. But we've got lots of different options for teeth. If you're not sure what they all are, there's a button here that says make all teeth, and that will take your existing configuration that you have open and make all variations of teeth. So just to show you what you've got, we looked at none earlier. We've got triangle, it's probably the most standard one. We've got flat triangles. We've got rounded, like this. There's a semicircle on the end of that. We've got rectangle teeth, spade teeth, W-shaped teeth, or Batman-shaped teeth maybe. Semicircular teeth, and if there's interest, we can also modify this to add more options in the future, in future versions. So lots of options for inner teeth. We also have outer teeth. So if I turn on outer teeth, we'll have a rectangular. Let's have a spade outside tooth. And you'll see now the outside teeth, so one outside tooth on either end, is going to be a spade tooth like this. We can increase the number of these. Let's say we have 2. And we can also make them bigger. So let's make them, let's say, twice as long and twice as wide. And we'll generate that. You see now we have 2 outer teeth on each side of the belt, and then inner teeth as well. So there are lots of options here we can play with. Again, just delete, generate each time, play with your options until you get the belt you're looking for. So let's make that small again, and then we just have a belt that looks like this. So those are the inner teeth, those are the outer teeth options. Probably the next most interesting one to look at is the form. Lots of options in here, but one of the easiest ones to look at here is the belt length. So we can make a belt that's 2 meters long, but only 200 wide, let's say. So we'll get here, we have our outer teeth, just 3 inner teeth, and then we have, a very long belt. We can, of course, vary that. So we have one that's 400 long, but 1 meter wide. We can go ahead and generate that. Again, lots of teeth here, a very wide belt, but not very long. We'll go back to a kind of fairly standard belt like this. This is also where we can start playing with our form. So there's a standard belt there. If we wanted to make an angled belt, we can go ahead and make the form of the belt to be angled. And now we have the join angle here at 45. And we get a 45-degree join in the belt. Note that the teeth form is modified to match the angle of the belt. Okay, we can delete that, we can change the angle, let's say 60 degrees. It's important that when you change these, you leave the box so that the edit takes place. Now we generate it, we get a much steeper angle. We can of course take it all the way to 90 degrees, and we'll get back to a straight belt. We can also go ahead and go to our circular form, and in the circular form we're going to be using these 3 options here at the top. The belt angle, which is the angle the belt is going to sweep through, the inner and outer radius. So if we generate that, you see we get about 135 degrees of belt. We can make that smaller, let's say 65 degrees. And we can generate that. We can obviously make it much longer. And we can of course change the outer radius as required, so we get a much thicker belt. So lots of options there to explore, and again just select it, delete it, generate it. You can generate multiple belts, just move them out of the way, and then you can arrange the whole day's orders in this way. But of course you can also save the configuration, give it a name in here. And then that's something that you can then refer back to if that's a common belt that you make. Okay, so we're back to a kind of very straightforward belt here. The next thing to talk about is the fittings. And the fittings have a bunch of options, but we'll go through them slowly. So probably the most interesting one here to talk about is the form of the fitting. We've just been generating circles here. These appear on the holes layer, on the fittings layer, which is yellow in this case. So we've been doing circles, but we can also do points. Points are very useful if you're going to be using a punch tool, because you can then define where the punch is going to take place exactly on that dot there. Points are really nice because you can always see them. Doesn't matter how zoomed in, zoomed out you are, you can always see them. We've got the ability to go ahead and do different types of forms, but probably the most interesting thing to talk about is going to be the pitch. So if I increase the pitch, make that, let's say 75, and we generate, it's going to tell me that that didn't divide cleanly, so I'm going to actually go to 100 pitch. There we go, so now we get a much more spaced out. If we go down to 25, just see the difference here, like that. Now you might wonder why in the top case we have all of the punch points but on here we have not all of them, and that's because we have the option here which will do the fittings per punch. So we have a punch tool separate to the machine which can punch 15 holes at a time. The end of 2 of which are going to be the guide holes. So in this case, this belt would require a punch here and then a punch here using a separate die punch system. We can vary the number of holes that are on the punch. Don't forget to count the guide teeth as well. So we'll go ahead and generate that. You see we get many more punches. If there's an odd number of punches that can't be punched precisely, the machine will punch the additional holes at the ends as well as the guide holes there. Okay, the other options for fittings, there's quite a few. We'll just work through them slowly. So the first one here is the inset. So if you want to offset the hole from the edge of the belt, from where the teeth are, you can do that using this. This value cannot be larger than the pitch. But if I want to generate that with a 10mm offset, I'll just make that and then show it to you separately. So we'll try with a 10mm offset and without a 10mm offset. And if I just overlay those two, you'll see that everything is very slightly offset. So it just moves the holes away slightly from the join at one side, but of course it moves it closer on the other side. So that's an option you can explore if you need it. We talked about the pitch. The inset is from the top and bottom of the belt. So if I change that to be 100, say, and we generate, and I generate that again with only 50, you'll see we're controlling how far in from the sides of the belt the fittings are placed. Of course, it's really down to you to calculate where that needs to be. For example, if you want to try and put it in the middle of that spade tooth, we could analyze the distance of that. So we could go ahead and measure that as 21mm. So if we put the inset to be 21mm, we delete that and come out of there. At any point, if you're not sure about settings, you can of course just validate, make sure it's valid. Any messages with any errors will appear in that bottom box. We can generate. Now you see we get our fittings being generated inside the teeth. If you don't want fittings inside your teeth, you can turn that off. And then we can generate again. And now the fittings stay outside of the teeth on both sides. Up to you, you've got the control of it as you require. If you're using other types of geometry, let's look at circles. We can control the radius of the circles using this fitting radius option. So this will generate quite large fittings. Obviously you need to be careful they fit within your teeth geometry. You've got a lot of options here and you need to be intelligent about how you change them. Obviously you can do much smaller circles as well if that's what you require. You must make sure you leave the box in order to have the edit take place. Much smaller circles there. Now if you wanted to have all of the circles punched by the machine, we would just say fittings per punch is 1, for example, and then that will generate everything. On circular belts, it will ignore this fittings per punch because you don't have tooling that's able to do that. If we have rectangles, then the fittings length and fittings width come into play. So if we make that just slightly different, we're getting very large rectangles. Let's make our pitch maybe a bit bigger. Again, important that fittings pitch divides cleanly into the length of the belt. So we'll do that at 100. You see we get our rectangles there, and we've got control of it through the length and the width. If we have slots, I'll just show you the two options for slots. Slots are basically rounded rectangles. So there's a slot on the width. Again, we can change the sizes to make it fit. And a slot on the length is like this as well. So you've got all the options there. If you're ever not sure, you can obviously make all fittings, and you'll see all the options there. None, points, It's very useful for when you're punching with the machine. Circles, which you need a knife blade for. Rectangles, again you need a knife blade. Slots along the width and along the length. And in future releases we can add additional if that's required. But those are the options for fittings. They will apply to any belt that you want to draw, any belt form that is. So I need to make sure I leave that. Generate that again. Yep, there you go. So you know you've got the fittings on an angled belt if that's what you require. Okay, we've talked about form, we've talked about fittings, we've talked about in and out of teeth, and we're going to talk about additional fabrication. A lot of options in here for a lot of functionality. I think rather than go through each of these, I'll first just show you all the options for fabrication. We'll start at the bottom here. None, there's no fabrication inside the belt. Center line, again we're just controlling this option here. We'll put the line just on the center of the belt. And if you have a circular belt, that line will be a radius in the center of the belt. Single lines go along the length, dashes break that up, lines on the width go across the belt. I think they may also be known as flights. We can also have rectangles, we can have points, we can have circles, we can have grids of circles, and we can have what's called domino circles, where every other line of circles is offset by half of the pitch. So there's a lot of options in here. I would recommend just exploring and trying them out as we've been doing so far. The key things to look at then, we want to be aware of the margins on each side, both in the width and in the length. That controls how far in the fabrications will start. Obviously that needs to be beyond your fittings if you have any fittings, and potentially away from your teeth as well. So you've got control over that in both options. You've all got the pitch on the width and on the length, which control how many, for example, points you're going to get. So fittings and the length will control the spacing of the points horizontally in this case. You've got the pitch in the width, so that's going to control that there's only 3 rows of points here. Then you've got the fitting length and fitting width, and that will control things like the size of these rectangles there, or it would control kind of the spacing in which the circles are placed. It also controls the length of these dashes, would be this fabrication length there. Those would be 75 millimeters long in this case. If you're using the circles inside, the multiple circles here, you can control that using the internal pitch on the width and the length, and that will control the spacing of these circles within the rectangles. And any circles that you make, the radius is controlled here by this 5 millimeter thing here. So a lot of options, but a lot of functionality, a lot of control, and they all kind of make sense reasonably intuitively. Just need to make sure you change the correct pitch. Remember, the internal pitch applies within the fitting, in the rectangles, and the pitch here, fabrication, controls the spacing of the rectangles of circles. So again, lots of options there. Best really that you explore to try and make what you need. Of course, don't forget that you can use this as a starting point, and then you can use Rhino and all the tools within Rhino to modify the belt that you've generated. So for example, if I wanted just 2 lines, I didn't want this center line, I could just ungroup. So I just selected it and I typed in ungroup. I can then just go ahead and select individual geometry and delete it. So I could delete the central line from that if I needed, or I can add other fabrication marks here as well. Perhaps some pen marks for later fabrication, perhaps additional cutting, whatever you need, you can use Rhino to do it. The generator is essentially a time saver from having to draw all this manually, but you can edit this as required. So that's fabrication. The remaining things to talk about then we should talk about the options under material. Now this is really used for sizing the belt correctly. So we're going to try and make a belt that's 1 meter long and 400 millimeters wide. And if we were to try and make, let's say, a 10 meter belt, so that's 10,000 millimeters long, 10,000 millimeters long, we could start saying we want to fit the belt to the material, and we could say that our material is only, let's say, 5 meters long. So the belt won't fit into the material that we have. If we've got fit to material turned on, when we generate, we'll get, in this case, 3 belts generated. Okay, so we've got 3 belts generated, so it's normally one more than the division of these two numbers. So 10,000 divided by 5,000 is going to be 2, and we're going to generate one more than that because we need a little bit of additional length for the teeth joining each belt. So if you want to check what it's generated, the way to do that is to get Analyze, Distance, and then select from the end of the tooth all the way to the other side, to the outside of it. That gives you the distance there, so 3.333 millimeters. We've got 3 belts. If you times that by 3, you'll get exactly 10 meter belt. Really important that you measure it from kind of the shoulder of the belt to the end of the belt on the other side. Otherwise it won't match, but it does create the correct belt, and if you put those 3 together, you will get the correct measurements. So let's change our example a little more, and let's assume we want to create a very wide belt. Let's try to make it 4 meters wide, but again we have our material width as only 2 meters wide. So we can go ahead and generate that, and you'll see we've now generated 6 pieces, because again it won't fit in that side. So note that it's only generated 2 in the width, because the width will divide precisely. There is no teeth along the width of these belts. Maybe that's something we can add in future if that's required. If you want a way of checking this, a nice little trick is to use the array command. Number in the x direction will be 3. Number in the y direction will be 2. Number in the z direction will be 1. And the x spacing will be, again, select from the shoulder all the way to the end of the belt, just there. And then we should be able to also do that in the other direction. That was my fault. I've done that wrong. I should have selected to the opposite corner. Let me do that again. So if you hold down Alt and then use these arrows, you can create copies. So if I do that again, we're just going to array 3 in the x direction, 2 in the y direction, 1 in the z direction, and the spacing is from this shoulder all the way to this point here. You'll see that then generates our belt. And if we go ahead and analyze the distance, we can analyze the distance from the shoulder all the way to the top, to the other shoulder, 4 meters, exactly our width, and we can check our length. The length here is exactly 10 meters. So it's a good way of being able to size belts appropriately. If, by the way, you want to have a little bit more control on this, let's just go back to our example where we're just changing in the length. We'll just do short belts that we know will fit in the width. If you want to say, well, rather than 3 pieces, I want to have 4 pieces, you can set the minimum number of pieces to be what you require. And when we generate, that should have generated 4. I will resolve that. That should have generated 4. I will fix that. The other thing that we can do is we can change the belt orientation. So we're going to go back to an example that does fit and we'll just make it 1 meter long. So far we've always been generating things horizontally, but you can also generate your belts vertically if you require, and you'll see the belt will come out like this. So you've got control of it in that way, and when you change the setting, the material length and width will flip as required to make the belt appropriately. But generally we'll have this fit material turned off, and generally you'd only generate horizontal belts, and you would later use nesting to do the rotation of the belt to the orientation that you require. Okay, so there's a lot of options there for the modern belt generator. You've got the teeth options, inside outside, fittings options, you've got the fabrication options, and you've got the material fitting as well. If you're ever not sure, you can obviously generate all the options for teeth, for fittings, for fabrication. You can have a look at exploring some different join angles like this. And if you want to just explore all the options, you can of course make random, and you can see lots of variations that you could then explore for later fabrication. So yeah, that's the modern belt generator. Hopefully that's going to save a significant amount of time over generating these manually, and yeah, a great way of being able to use ZebraCut for speeding up production. Any questions, please do get in touch. We'd love to talk with you. Thank you.